Hi, my name is Tim Nechtel. I'm a principal technologist with Caprivi Solutions. I've been asked by K2 to put together a presentation and a demonstration showing a proof of concept that Caprivi Solutions did, proving out that K2 Blackpearl works with Microsoft Server clustering. So before we actually get into that, I wanted to take you through what I'm going to present today. So firstly, we're just going to level set and take a look at some of the Windows clustering vocabulary. Then we'll look at some of the different clustering technologies that Microsoft offers, specifically network load balancing, as well as server clustering, which is what we're proving out with this demonstration. And then we'll actually answer the question, well, why would we actually want to use a server cluster with a Blackpearl? And after that, I'll bring up some additional resources that you can reference if need be. So here I'd just like to level set around some of the clustering technology vocabulary, because some of these words can be used and are used interchangeably, which can lead to confusion for people that aren't actually familiar with the different clustering technologies Microsoft offers. So a cluster itself is simply a group of independent computers that work together to run a common set of applications and provide basically an image of a single system to the client in the application. So from the end users, it appears that they're accessing just one server that exists on the network, while in reality, there's typically two or more systems that are running in the background, accepting that load and responding to it as need be. And then there's the nodes or hosts. So each system in a cluster configuration can be referred to as a node or as a host. And Microsoft offers two different types of clustering technologies. There's Windows Network Load Balancing, and what it does is it network load balance clusters that distribute the client requests or TCP IP traffic amongst many servers within that network load balance cluster. And the other technology is often referred to by the acronym as MSCS, which I'll use during the presentation, as well as it's referred to as server clusters. And server clusters provide a failover of resources representing the services, applications, and the base operating system features between servers in the cluster itself. Okay, so with just some basic vocabulary out of the way, let's take a look at the Windows clustering and the big picture. So here we have clients on the left-hand side. They're accessing information, in this case, with the network load balancing. And using network load balancing, whether or not it's hardware or software, but Microsoft just provides of course, the software load balancing. You can have up to 32 different servers that make up that network load balancing cluster. And so typically it's load balancing web applications, but not necessarily just web applications. It can be other IP-based services. And then in the back end, here we have our server cluster running, which normally most people would be familiar with this, with having a SQL cluster that is where the backend database information is stored. However, it's not just limited to SQL. You can also cluster your Exchange servers, or you may just actually choose to cluster services that are available on your Windows servers. Things like your data files or your file shares, your print servers, and so on. So those capabilities are there. And of course, other third-party applications can also be written to support cluster services as well. So how does K2 fit into the Windows clustering technologies? So by default, K2 supports running the K2 Blackpearl server with the K2 workspace in the network load balancing area. And so in that case, when users then are retrieving their work lists within a particular process, or they're running reports on the K2 workspace and so on, those can actually be, that load can be distributed using network load balancing. And so you would install K2 Blackpearl on each of the servers within your network load balancing cluster, and as users connect up, it would then distribute that load across the different servers. Then the other way that K2 supports the Windows clustering technology is it supports installing the K2 databases on the SQL cluster, and so that provides for high availability in case one of the servers within the SQL cluster goes down. Then the server cluster will detect that and basically fail over the node to another SQL server running in the cluster, and your K2 servers will then just simply access a separate database, and all that will happen seamlessly. So that's kind of the out-of-the-box how K2 Blackpearl works with Windows clustering technology. However, there's going to be situations and there's advantages when actually using K2 Blackpearl with a server cluster. So that's what we're going to talk about. But first off, we'll look at, well, what are the advantages around the different Windows clustering technologies? And the first off is network load balancing. So some of the advantages with that, there's no single point of failure, although you can say that the Windows server cluster provides that same capability. But the big advantage is there's no special hardware required. So you can just take kind of out of the box, run-of-the-mill type of server hardware, and you can add it to a network load balancing host, or to a network load balancing cluster as an additional host, and it'll just distribute that load. And because of that, it makes it very easy to scale out by adding additional nodes to the cluster. And with Windows Network Load Balancing, it supports up to 32 nodes in that cluster. So some big advantages there. And then for server clusters. So with server clusters, it works a bit differently in that you require specific hardware to be able to run a server cluster. And specifically, most of that hardware requirements comes into the disk technology, where it requires a multi-initiator SCSI or SCSI over fiber channel hardware sets. But there's some big advantages for using server clusters, and in that the server clusters offers fault tolerance of resources, services, and servers themselves. So unlike with network load balancing, where it's working at the network layer, so if one of the servers goes down, if it can't talk to one of the servers within the network load balancing cluster, then it simply goes ahead and redirects that user request to another server. However, if there's a dependency, like say the K2 Blackpearl service goes down, which admittedly doesn't happen very often, but the possibility is there, the network load balancing will not automatically detect that. And so the users may actually be still directed to that server because that server itself is up and running and accepting requests. It's just that that one dependent service is not running, and so the users will receive some timeout or an error message. So that's what server clustering, one of the big advantages. So it offers fault tolerance of the resources, the services, and the servers themselves. And it enables you to monitor at the resource level and customize dependencies. So we can say that, okay, so the Blackpearl service depends on these additional services. And if any of these go down, then let's go ahead and fail over to another server inside of that server cluster. So you can configure the failed cluster groups to, of course, automatically fail over, but it may there may be advantages as well to simply go ahead and restart some of those dependent services before attempting the failover. So with that being said, the big advantages for using server clustering with K2 applications, so K2 Blackpearl, would be specifically a failover if the K2 host service fails, or a failover if K2 software dependencies fail, like the Microsoft Distributed Transaction Coordinator or MSMQ, which Blackpearl depends on. And for the proof of concept that we actually proved this out for, it wasn't actually the top two requirements, the top two advantages. What really we needed to prove this out for was in a very specific situation where there was actually rack space limitations, where the potential customer couldn't add any more hardware to their configuration. And Microsoft doesn't actually support running both network load balancing and server clustering on the same server. So the customer already had a server cluster for SQL set up, and they couldn't install two additional servers to host the K2 Blackpearl application. So the only available option was to actually run K2 Blackpearl on their server cluster. So that's what we actually proved out, and that's what we'll show in the demonstration. And before I get into the demonstration, here's just some additional references that you can look up on the Microsoft website that discusses more detail the Windows clustering technology, as well as specifically network load balancing and Microsoft server clustering. Welcome back. Once again, it's Tim Nectel from Caprivi Solutions. What I'd like to do now is to demonstrate the proof of concept that Caprivi Solutions was asked to present by K2, showing how K2 Blackpearl can work in a Windows Server cluster environment. So in the environment that I set up, I have my domain controller, which is also acting as my client machine as well, and so that server name is just my DC. And then I have two cluster nodes, and so those servers are set up as my node 1 and my node 2. Okay, and of course on each of those nodes, I've installed Windows clustering services, as well as I've configured a SQL Server cluster group, so it can monitor the SQL databases and of course the K2 Blackpearl databases. And when doing that, also set up some dependencies around that SQL Server, as well as K2 actually requires around the Microsoft Distributed Transaction Coordinator. So those are set up in different groups. So we have the SQL group. Note the SQL network name, SQL Server, SQL Server agent, and so on. Microsoft Server Distributed Transaction Coordinator. And then, of course, the K2 cluster group. And so configured the K2 cluster group and have added some additional resources. So some of those resources that it'll depend on are, of course, the IP address for the virtual cluster, the cluster name itself, which in this case is k2cluster.mycluster.com, and the K2 service. So when we look at the properties of this, it's set up as a generic service, and then I can configure the dependencies. And in actual fact, I probably wanted to have added MSMQ and any other server resources or applications that K2 Blackpearl or the processes may actually depend upon. And then we have additional parameters. So here's a parameter for the K2 Blackpearl service, the startup parameter, and can click on OK. So this is then monitored as an application by the SQL cluster service itself. Okay, so with that being said, let's just go ahead and see what this would look like from first from a K2 administrator perspective, and then how we'll go ahead and test out a process and test out the failing over node of the K2 Blackpearl cluster and see how the actual process responds to in the user interface. So switch back to the client machine, bring up the K2 workspace, go to management and the management console. Expand this out, and as you can see, this looks very similar to as if you had configured K2 Blackpearl in a network load balance environment. So here we have the cluster name, workflow server, and of course behind this virtual name here is we have two physical servers. But with in the server clustering, one of those nodes is actually offline. I can expand out my processes, and here's a process I'm actually will be initiating that I've already deployed. So let's take a look at that particular process. So here we have a simple process, a start activity. Then we have two client activities in here using the default client event, which will just display a web page that will allow the user to approve this or reject it. It's the destination user is the originator, and then the next event within each of those activities is just a smart object event, which goes ahead and inserts a new record into a smart box, a smart object. So that's just a test set. We're going to initiate this workflow. It's automatically going to assign these client events to the originator, and then we're going to respond to one of those activities. It'll then go ahead and initiate. We'll fail over one node of the cluster, and then we'll go ahead and respond to the other activity. So I'll go back to the K2 workspace here. I'll manually kick off this process instance. Click on Start New, and then click on Start. Okay, so it's saying it's currently active. The originator is myself as the administrator. If I refresh user's work list, and then we have the two activities that have been sent to me. Of course, it doesn't matter what order it comes in. I'll just bring up that view flow diagram so we have it running there in the background. Click on the link to actually bring up the web form. And so here we can see I'm actually querying that smart object that will populate after this event after this client event is finished. So right now the current ID is 16. So we'll simply go ahead and I'll choose to reject this. Refresh my work list. We'll see review activity 1 has completed. If I look at my view flow, click on refresh, and we can see the path that is followed. Okay, so now let's get down to the crux of the matter, and let's go ahead and fail over one of those nodes. So I go back to one of my nodes here, my node 1, go into the cluster administrator. Here we can see that right now this is the K2 service is actually running on my node 1. Let's go ahead and choose to move this group. I feel like I should have a drum roll or some music playing here. First time in the wild that K2 fails over in a cluster, Windows Server cluster environment. So we can see it took it offline, and now it's online pending in my node 2. And it should be up and running. So let's switch back to the client. I can go ahead, click on the link. It'll bring up it's bringing up that client page. So with basically very little or no user disruption. And here we can see that the smart object insert event went and fired for the review activity 1, which was completed. We can see the time in there. I'll go ahead and approve this. Click on submit. It's been initiated. If I look at the view flow and click on refresh. Okay, so that's a quick demonstration of using K2 Blackpearl in a Windows Server cluster environment. So some of the things that we proved out. We proved out that we can go ahead and we can initiate a user process. We proved out the K2 workspace, which worked with basically with very little additional configuration. The reports in that were configured more or less exactly the same way they would be in a Windows network load balance environment. And then we went ahead, we initiated a client event. Sorry, we initiated a process. We finished the one client event. We then failovered the one node of the cluster. And then we brought up the user's work list basically with no interruption. Finished that work, and K2 Blackpearl worked perfectly in this Windows Server cluster environment. So with that, I'd like to thank you for your interest, and if you have any additional questions, you can contact me. My name is Tim Nechtel from Caprivi Solutions, and you can email me at tim.nechtel@caprivisolutions.com. Thanks very much, and have a good day.